Okay, so let's talk about why the pH doesn't change dramatically until you reach close to the equivalence point. So you call those buffering regions in the pH curve. The reason those pH changes are so minor is because of the way pH is calculated, the behavior of hydroxide and hydronium. So check this out. I've just got a solution with a hydroxide concentration of 4.4 times 10 to the negative 4. I want to find the pH and then we're going to do stuff with it. Okay, so we can get the pOH really quickly. Maybe I'll do that. Okay, so it's a logarithmic scale, which later in your university studies, hopefully you see different logarithmic scales, and they have interesting properties, and this is one of them. Okay, so I can calculate pOH from this. Okay, I get 3.36. Okay, so pH, we just need to subtract that from 14. And we're going to get 10.04. Okay, actually 10.64. My mistake, there it is. Okay, so that's very highly basic, all right? What's going to happen if we cut that in half? Cut the hydroxide concentration in half. So that would represent in a titration, you know, half of the hydroxide's gone. We've added acid until we're only left with half the original base. Let's see what happens to pH. So we'll do pOH again. Okay, 3.66. And then pH, subtract that from 14. Okay, I think I can do math in my head this time. I get 10.34. So even though half of the base is gone, pH only decreased by about 0.3, which isn't much, all right? For you math people, that 0.3, the significance of that is that's just log of 2. Okay, so when you cut it in half, you subtract log 2 from the pH. That'll make sense if you think about it. Now let's go crazy a little bit. I'm going to cut the concentration of hydroxide by 10. So 1/10 the original concentration. So that would represent 90% of the base being gone. What's going to happen to the pH? Okay, you'd expect a huge change, but let's find out. Okay, the pH is still 9.64. And if you know how logs work, that should make sense too. If we have 1/10 the amount, pH goes down by 1. Okay, that's how a logarithmic scale works, by factors of 10. This is still strongly basic. So even when 90% of the base has reacted, your pH only goes down by 1. All right? But to react 90% of what's left, you'd get another pH change of 1, which would be much less than the 90% to get here. Right? 90% of this is less than 90% of this. What happens is you get close to the equivalence point where there's more base than acid, but the amount more is less than 1 drop that you add. So that 1 drop, it's a couple milliliters. We go from an excess base to an excess acid, and your pH might change from 9.6, you know, to 5.6. That'd be a huge difference, and you'd see that in the pH curve.